All right, here we have a car that starts at rest. It's going in a circular track. It's 30 meters long. Its velocity is increasing at 0.5 meters per second squared. The question is, what is the net acceleration 15 seconds later? All right, so alpha equals a tangential, right, uh, divided by r. Right, so we got our tangential acceleration, and let me back up and rephrase that. The tangential acceleration, which is what we have, the 0.5 meters per second squared, is alpha times r. All right, and I didn't need the other way around. And so we're looking for alpha equals a tangential over r is 0.50 meters per second squared. Let's stick all of that in parentheses and divide by r, which is 30 meters. Okay, so alpha 0.5 over 30. I'm not actually positive I need that. 0.0, 0.0, 0.01667. All right, per second squared. Okay, so what is the magnitude of net acceleration 15 seconds later? Well, what is its tangential acceleration 15 seconds later? All right, tangential acceleration 15 seconds later is still 0.500 meters per second squared. What is its tangential velocity? Its tangential velocity is 0.500 meters per second squared times 15 seconds. 0.5 times 15 gives us 7.5 meters per second. All right. So, if the tangential velocity is 7.5 meters per second, what does that say about the centripetal acceleration? Is Vt t squared over r, right? 7.5 meters per second squared divided by 30 meters. So 1.875 is the meters per second squared, is the centripetal acceleration. Okay, what is the magnitude of the net acceleration 15 seconds later? So we have the tangential component, 0.5 meters per second squared. We have the centripetal, or in your book, the radial component, pardon me, the radial component, 1.875 square meters per second squared. Those are perpendicular to each other, so the magnitude of the acceleration, of the total acceleration, I'll put that in there, total, is square root of a tangential squared plus a radial squared equals 0.5 squared plus 1.875 squared. I'm going to stick the units out here, meters per second squared. Okay. Square root 0.5 squared plus 1.875 squared, 1.941, we'll call it 1.941 meters per second squared. So that is the magnitude of the acceleration after 15 seconds. What angle does this net acceleration make with the car's velocity at that time? Okay, so the car's velocity is in the direction of the tangential acceleration. And so what we're looking for is, what is the angle made between, let me redraw this, All right. Car's velocity is in the direction of tangential acceleration. So what we're really looking for is the angle between the tangential acceleration and the total acceleration. So we're looking for theta to be inverse tangent of the radial acceleration divided by the tangential acceleration. So in part B, theta is inverse tangent of, okay, a radial divided by a tangential. Equals inverse tangent of a radial is 1.875 divided by 0.5. Okay. A tan of 1.875 divided by 0.5. And now we have to convert that to degrees, unless you guys think in terms of radians. So 75.1 degrees. 75.1 degrees. And that's the angle that the acceleration makes with the tangential velocity of the car. And that's it for problem 32.